prove by induction that 5 to the power of 2n minus 2 to the power 3n is divisible by 17 for all positive integers. Okay, so in order to prove something by induction, we must prove that it is true for the base case. Then we must prove that it is true in all other cases. So let's start with the base case. So for the base case, we're going to set n equal to 1 and say if n is equal to 1, do we get something divisible by 17? Well, let's see. If n is equal to 1, that means we have 5 to the power of 2 times 1 minus 2 to the power of 3 times 1, and that's equal to 5 squared minus 2 cubed, which is equal to 25 minus 8, which is equal to 17. Now 17 is of course divisible by 17, that's for sure, so therefore we can give a check to our base case. We have done it. Okay, now we need to make sure that this is true for the other cases as well. So let's consider n being equal to k plus 1. It needs to be true for all of these cases. So if n is equal to k plus 1, we're going to have 5 to the power of 2 times k plus 1 minus 2 to the power of 3 k plus 1, which is equal to 5 to the power of 2k plus 2 minus 2 to the power of 3k plus 3. Okay, now we're going to split these up into 5 to the power of 2 times 5 to the power of 2k minus 2 cubed times 2 to the power of 3k. That is going to give us 25 times 5 to the power of 2k minus 8 times 2 to the power of 3k. So we can split the 25 up into a 17 and into an 8. So this is the same as 17 times 5 to the power of 2k plus 8 times 5 to the power 2k minus 8 times 2 to the power of 3k. So clearly this first part already works out for us. It already is divisible by 17. So 17 times 5 to the power 2k is good to go. Now we need to find a way to make this second part equal to something that is also divisible by 17, because the whole equation must be overall. So I'm going to factor out this 8. We're going to have 8 times 5 to the power 2k minus 2 to the power of 3k. And then that is going to be the same thing as 17 times 5 to the power 2k plus 8 times 17 times something, right? We know that this part here is divisible by 17. And so then we can just do a common factor of 17 from the full thing and get 17 times 5 to the power of 2k plus 8s, like that. And there we go. This is clearly divisible by 17. So therefore, because this is true, it is true for n equals 1 and n equals k plus 1. It is true for all positive integers. And there we have it.